Hi guys, let's start a new exercise of the chapter ratio and proportion. But before we start, let's revise what we did in the first exercise. We talked about four non-zero numbers being in ratio, being in proportion rather, which is A is to B is equal to C is to D, which means A and D were the extremes, B and C were the means. And we had A into D is equal to B into C. Then we talked about continuous proportion or continued proportion, where three terms are in proportion, which means A is to B is equal to B is to C. If you write it in the fraction form, this will be A upon B is equal to B upon C. And then if you cross multiply, you get B square is equal to AC. This is the mean proportional. Perfect. So this is what our first exercise was about. Now let's look at the second exercise and look at certain properties of ratio of proportion. So let's look at an example. It's saying if A is to B is equal to C is to D. So let's say 1 upon 2 is equal to, let's say, 3 upon 6. Yes, both of them are this in proportion because 1 into 6 is 2 into 3, or if I simplify this, this is 1 is to 2. Perfect. So we are looking at A is equal to 1, B is equal to 2, C is equal to 3, and D is equal to 6. So that's the given number. Let's see what does invertendo, which is a first property of proportion. What it means is if 1 upon 2 is equal to 3 upon 6, 2 upon 1, which is if I take the reciprocal of one side, I will take the reciprocal of the other side as well, which is it will become 6 upon 3. So this is 2. We know that 2 is equal to 2. So this is the property which is known as invertendo, which means if you take the reciprocal of one side, then you take the reciprocal of the other side as well, which means if A upon B is equal to C upon D, then B upon A would be equal to D upon C. This is invert, which means invert it, reverse it, right? This is invertendo. In the ratio form, I would write this as B is to A is equal to D is to C. Fairly simple. We've been doing this forever, ever since we started doing fractions, but this is a new name that we are giving it, which is called invertendo. Good. Let's look at the second property, which is called alternando. Let's again go back to the numbers. It's easier to understand with numbers. We talked about 1 upon 2 is equal to 3 upon 6. Let's move 2 to the numerator and let's move 3 to the denominator. This becomes 1 upon 3 is equal to 2 upon 6, which is 1 upon 3. Yes, that's correct. So this is the property which is known as alternando, which means you alternate it, which means A upon B is equal to C upon D. This means A upon C is equal to B upon D. Perfect. We also, if I write this in the ratio form, I would write this as A is to C is equal to B is to D. Now in this case, I inverted 2 and 3. I could have also inverted 6 and 1. It would still get me the same result, which means 6 upon 2 would be equal to 3 upon 1. It will give me the same result, which means now I would write this as C, which is 6, which is D, upon 2, which is B, is equal to 3, which is C, upon 1, which is A, which means D is to B is equal to C is to A, which is exactly the same thing, but the invertendo of it. In this case, B is in the numerator, D is in the denominator. Now I have D in the numerator, B is in the denominator. So exactly the same thing, which means you are alternating, which means one numerator becomes the second side's denominator and one denominator becomes the second side's numerator. Again, we've been using this forever, but a new name being given to it, alternando. Next, let's look at componendo. Now, componendo says if A upon B is equal to C upon D. Before I get into this, let's go ahead and do something which we already know. So 1 upon 2 is equal to 3 upon 6. That's given. Let's add 1 to both the sides. Yeah, that's allowed. In an equation, I'm allowed to add uh, same number to both the sides. So if I add 1 to both the sides, I will take the LCM. The LCM is 2. This will become 1 plus 2. And here the LCM is 6. This will become 3 plus 6. This is 3 upon 2 is equal to 9 upon 6. 3 into 2, 3 into 2. That's correct. We know that this is correct. Now what this means is if A upon B is equal to C upon D, if I add 1 to both the sides, which means a upon b plus 1 and c upon d plus 1, the LCM is b. In the numerator, I get a plus b. The denominator is d. In the numerator, I get c plus d. So this is componendo. A plus b is to b would be equal to c plus d is to d. Please remember this. This is one of the most important property that we'll be using. We have been adding it. We've been using this property as such, but we've not been using it as componendo, which means we've been using the property of adding the same number of both the sides. But in the case of a proportion, we've not been using this property. So this is completely new, which is componendo, which means you add the numerator and denominator divided by the denominator, and the same thing on the right hand side. So a plus b upon b will be equal to c plus d upon d. Good, let's look at the next set of properties. So we've done 3 till now. One was invertendo, which means you take the reciprocal of both sides. The second was alternando, which means you replace numerator of one side with denominator of the other side. And the third thing which we did was componendo, which was a plus b upon b is equal to c plus d upon d. Perfect. Now let's look at the fourth property. So there are 5 properties. Let's look at the fourth one. Again, we are looking at the 4 numbers. 1 upon 2 is equal to 3 upon 6. So this time I subtract. This property is known as dividendo. Last time I added, this time I'm subtracting. So let's see what happens if I subtract. So this the numerator, again I take the LCM, that's 2. So this is 1 minus 2. On the right hand side I have 6, and this is 3 minus 6. So this is negative 1 upon 2 is equal to negative 3 upon 6. That's correct. Now let's do it with AB. So A upon B minus 1 is equal to C upon D minus 1, which means A minus B upon B is equal to C minus D upon D. So this is property is known as dividendo. In componendo you add, in dividendo you subtract. So let me write the previous property as well, which was a plus b upon b is equal to c plus d upon d. This was componendo and this is dividendo. Perfect. Let me give this equation 1. Let me call this equation 2. Now the last property, which is using both componendo and dividendo. So if it says if a is to b is equal to c is to d, then a plus b upon a minus b is equal to c plus d upon c minus d. So let's divide 1 by 2. Right? Let's divide 1 by 2. We've already got 1. We've already got 2. Let's divide. So this is a plus b upon b divided by a minus b upon b. And on the right hand side, I have c plus d upon d divided by c minus d upon d. This is division of fractions, which means I'll take the reciprocal of this term, and this division sign gets converted into multiplication sign. Similarly, on the right hand side, c plus d upon d multiplied with d upon c minus d. D and d gets cancelled, b and b gets cancelled. So what we are left with is a plus b upon a minus b is equal to c plus d upon c minus d. This is known as componendo and dividendo. So that's the final property which is there in your syllabus this year. Let's look at this for specific numbers. So we had 1 upon 2 is equal to 3 upon 6. It says a plus b, which means 1 plus 2 upon 1 minus 2 should be equal to 3 plus 6 upon 3 minus 6. 1 plus 2, that's 3. 1 minus 2, that's negative 1. 3 plus 6, that's 9. 3 minus 6, that's negative 3. So on the right hand side, I have negative 3. On the left hand side, I have negative 3. So this property holds good. This is just a proof of the example I have taken with actual numbers. Perfect. Let's go ahead and solve some questions now using these properties. So the most important property in this exercise or in this chapter would be componendo and dividendo, which is using both of them together. So let's look at the first question. First question is, if A is to B is equal to C is to D, prove 5A plus 7B upon 5A minus 7B. I notice that this is uh, in the form of adding something to the numerator and subtracting the same thing from the denominator. That's what we need to prove, which means I think we will have to use componendo and dividendo because it is adding and subtracting at the same time. I hope you remember componendo was adding, dividendo was subtracting, and componendo and dividendo was adding in the numerator, subtracting in the denominator. Perfect. So now let's see how we can go ahead with such a question. So this is what we need to prove. So 1 given A upon B is equal to C upon D. I notice that I need 5A and I need 7B. So let me multiply both sides by 5 upon 7. If I multiply both sides by 5 upon 7, I will get 5A and I will get 7B. Maybe after that I can apply componendo and dividendo. So this will become 5A upon 7B will equal to 5C upon 7D. Perfect. Using componendo and dividendo, we get number 3, 5A plus 7B upon 5A minus 7B is equal to 5C plus 7D upon 5C minus 7D. That's what they wanted us to prove. But in the question, they want us to write the answer in the ratio form. So let's write the answer in the ratio form. Therefore, 5A plus 7B is to 5A minus 7B is equal to 5C plus 7D is to 5C minus 7D. Perfect. I hope you've got the hang of using componendo and dividendo. Let's do one more question. This concept will become far more clear. Question number 1, part 3. Now again, what we have been given is A upon B is equal to C upon D. What we need to prove? To prove that XA plus YB upon XC plus YD is equal to B upon D. This time I notice that there is only addition. There is no subtraction being done. Yes, there is no subtraction being done. So maybe you should use only componendo and not dividendo, right? Because in dividendo, we obviously get a subtraction sign between the numerator and the denominator. I notice A has been multiplied with X and B has been multiplied with Y. So let's multiply both sides by X upon Y. So A upon B is equal to C upon D multiply by X upon Y. Yes, we are allowed to multiply both sides of an equation by the same number. So this becomes XA upon YB is equal to XC upon YD. Perfect. Now we realized originally itself that we are applying only componendo because there is only addition. So using componendo, what we get is XA plus YB upon YB is equal to XC plus YD upon YD. I notice on the right hand side in what they want, they have only B and D. So I notice I can get B and D if I take these two terms together. So if what I need to do is bring this down and bring this up, this property, if you remember, is called alternando. Yes, you are taking numerator of 1 to the other side, denominator. So using alternando, we get XA plus YB upon XC plus YD is equal to YB upon YD. Y and Y gets cancelled, which means this is exactly what they wanted us to prove, but they want it in the ratio form. So let's write it in the ratio form. Therefore, XA plus YB is to XC plus YD is equal to B is to D. Hence proved. Good. Let's look at the next one. The next one that we're doing is question number 3. Question number 3 says, given A upon B is equal to C upon D, prove 3A minus 5B upon 3A plus 5B. Okay, and this question appeared in your board exam in 2000. I notice it has both addition and subtraction, so we are basically using componendo as well as dividendo. I notice A has been multiplied with 3 and B has been multiplied with 5. So let's go ahead and multiply both sides by 3 upon 5. So A upon B is equal to C upon D. Let's multiply both sides by 3 upon 5. This gives us 3A upon 5B is equal to 3C upon 5D. Next, using componendo and dividendo, we get 3A plus 5B upon 3A minus 5B is equal to 3C plus 5D upon 3C minus 5D. In the answer that they want, the subtraction is in the numerator on both sides, which means I need to bring numerator to the denominator and denominator to the numerator. And the property that we use is called invertendo, right? That's taking the reciprocal. So using invertendo, we get 3A minus 5B upon 3A plus 5B is equal to 3C minus 5D upon 3C plus 5D. That's what they wanted us to prove. So hence proved. Wonderful. Let's look at the next question. The next question that we are doing is question number 4. It says if 5x plus 6y upon 5u plus 6v is equal to 5x minus 6y upon 5u minus 6v, we need to prove x is to y is equal to u is to v. Now notice if I have to use any form of alternando or any form of componendo and dividendo, then x and y have to be on the numerator and denominator. So maybe I can move denominator to numerator, numerator to denominator. So using alternando, what we get is 5x plus 6y upon 5x minus 6y is equal to 5u plus 6v upon 5u minus 6v. I hope you realize last couple of questions, we've been given x upon y is equal to u upon v, and we've been trying to prove this. This time it's the reverse, which means what we used to get has been given and what we need to prove is x upon y is equal to u upon v. Again, the properties still remain the same: invertendo, alternando, componendo, dividendo, and componendo and dividendo. So now let's try and use componendo and dividendo because we have plus and minus both. So using componendo and dividendo, we get 5x plus 6y plus 5x minus 6y upon 5x plus 6y minus 5x minus 6y, right? Numerator plus denominator upon numerator minus denominator. Same thing on the right hand side, 5u plus 6v plus 5u minus 6v. In the denominator, 5u plus 6v minus 5u minus 6v. Let's open the bracket. When I open the bracket, I get 6y and 6y gets cancelled. So this is 10x. In the denominator, I have 5x plus 6y minus 5x plus 6y. Similarly, this 6v and 6v gets cancelled and we have 10u upon 5u plus 6v minus 5u plus 6v. Perfect. Let's see if this helps us. Okay, let's see what we are left with. In the numerator, I have 10x. In the denominator, 5x and negative 5x gets cancelled. We have 12y. On the right hand side, in the numerator, I have 10u. And in the denominator, negative 5u and plus 5u gets cancelled. We have 12b. Let's multiply both sides by 12 upon 10, which means we will have 10x upon 12y into 12 upon 10 is equal to 10u upon 12b into 12 upon 10. 10 and 10 gets cancelled, 12 and 12 gets cancelled, 12, 12, 10, 10. And what we are left with is that this was y, right? 12y. So x upon y is equal to u upon v. That's what they wanted us to prove, but they want the answer in the ratio form. So we need to write our answer in the ratio form. Therefore, x is to y is equal to u is to v. Hence proved. Again, I hope you realize there is this only one property which we keep using again and again, alternando or invertendo. That's what. Okay, let's look at the next question. The next question that we do is question number 6, part 1. You can put a small star on this question. Let's see why. Okay, x is given equal to 6ab upon a plus b. We need to find the value of x plus 3a, which means I need somehow x upon 3a, because this will give me x plus 3a upon x minus 3a. Right? This term will come from x upon 3a. Yes, that's correct. For this term, I need x upon 3b, because if I use componendo and dividendo, I will get x plus 3b upon x minus 3b. I hope this logic is clear. If I need this part of my answer, I need x upon 3a, on using C and D, which is componendo and dividendo, I'll get this term. For getting the second term, I need x upon 3b, which will give me, on using componendo and dividendo, it will give me x plus 3b upon x minus 3b. Now that we've figured out what we need, let's see how we can get that. So let's, x is equal to 6ab upon a plus b. Since I need 3a in the denominator, let's divide both sides by 3a. Yes, so this will be x upon 3a, which is equal to 6ab upon a plus b divided by 3a. A and a gets cancelled, 3 1, 3 2. So this is x upon 3a is equal to 2b upon a plus b. I think we've got the first part of, right? When I use the componendo and dividendo, this will give me the first part. So now using componendo and dividendo, I get x plus 3a upon x minus 3a is equal to 2b plus a plus b upon 2b minus a minus b. All right, that's correct. Okay, so this gives me x plus 3a upon x minus 3a is equal to 2b plus b, that 3b plus a upon 2b minus b, that's b minus a. Let's call it equation 1. And now I hope we realize that we need x upon 3b. So this time let's divide it by x by 3b. So we have x is equal to 6ab upon a plus b. Let's divide both sides by 3b. When I divide both sides by 3b, I get x upon 3b is equal to 6ab upon a plus b divided by 3b. b and b gets cancelled, 3 1, 3 2, which means x upon 3b is equal to 2a upon a plus b. Again, using componendo and dividendo, we get x plus 3b upon x minus 3b is equal to 2a plus a plus b upon 2a minus b. Okay, let's see what this gives us. We get x plus 3b upon x minus 3b would be equal to 2a plus a, that 3a plus b, and in the denominator 2a minus a, that's a minus b. So we have our second equation. So if we need to find the value of what they want, let's go ahead and add them, which means from 1 and 2 we get x plus 3a upon x minus 3a plus x plus 3b upon x minus 3b is equal to 3b plus a upon b minus a plus 3a plus b upon a minus b. Now I notice that the denominator is exactly the same, but the sign has been reversed. So if I need to change the sign of the denominator, I change the sign of the middle, right? Whatever of the total number. In this case, the sign of the middle between these two terms. So this will become 3b plus a upon b minus a minus 3a plus b upon b minus a. All I have done is I have changed the sign. So now that the denominator is the same, I can go ahead and add, in this case subtract the numerator. So that would be 3b plus a minus 3a plus b. That would be 3b plus a minus 3a minus b upon b minus a. This is equal to 3b minus b, that's 2b, a minus 3a, that's 2a upon b minus a. I notice in the numerator 2 is common, so 2 times b minus a upon b minus a. B minus a and b minus a gets cancelled, and this is equal to 2. So the value of what they wanted is equal to 2. That's our final answer. Good, that brings me to an end of this video. Let me mark some homework questions for you. Homework for you would be question number 1, part 2, question number 2, question number 5. 3 questions. That's about it. Hope you like the video. If you have any questions or queries, feel free to write into me. Take care. Bye bye. I'll see you with the next video.